Hello and a good day. So we are from group 5. We'll explain about kinematics of motion in a straight line, which is chapter 3 from MAE 472. So our group will consist of 4 members, which are Nur Era Shahida, Nur Alia Natasha, Nur Ashikin, and also Siti Suad. And these are our learning objectives, which are students should be able to understand the concept of motion in a straight line. Students should be able to identify various type of motion graph. Students should be able to solve kinematics in calculus, and also students should be able to use formula for constant acceleration. As for introduction, what is actually a kinematic motion in a straight line? Kinematic motion in a straight line describes when an object's place or position changes with the time in its surrounding. Then, at that point, the body is said to be in motion.
What is kinematics? Kinematics is the study of objects move. Kinematics is the branch of mechanics that focus on object motion without taking consider the force that cause it. The kinematics of an object is described in terms of its distance, displacement, velocity, speed, and acceleration. So we move to the first one, which is distance. Distance is how far you travel in total, no matter the part you take. For example, if you walk in a zigzag, distance is the total number of steps you take along the way. It is scalar quantity, which means it only tells you how much, not where. We measure the distance in meters. The second one is displacement. Displacement, on the other hand, is the shorter straight line distance from where you start to where you end. Think of it as throwing a straight arrow from your starting point to your ending point. Unlike distance, displacement is a vector quantity, so it includes both how far and which direction. It also measures in meters. Next is speed. Speed is how fast something is moving. It only tells you the how fast part and not the direction, like running at 10 meters per second. Speed is a scalar quantity, which means it just has a size or magnitude. So next is velocity. Is similar to speed, but it also tells you the direction you are moving. For instance, running at 10 meters per second to is to the east. So this is different of displacement and distance. Distance is all the way from A to C to D and B. So for the displacement is the shortcut from the A to B. So the straight line from the starting point to the end point. Next is speed. Speed is how fast something is moving. It only tells you the how fast part and not the direction, like running at 10 meters per second. Speed is a scalar quantity, which means it just has a size or magnitude. Next is velocity. Velocity is similar to speed, but it also tells you the direction you are moving. For instance, running at 10 meters per second to the east is velocity. This makes velocity a vector quantity because it includes both magnitude and direction. So this is different of speed and velocity. Speed is simply how fast you traveling, and for the velocity is speed in the given direction. The last one is acceleration. Acceleration tells you how quickly your velocity is changing. If you are speeding up, slowing down, or even changing direction, you are acceleration. When the speed decrease, it's called deceleration or slowing down. Acceleration can be either a scalar or vector quantity, depending on whether the direction is considered. It is measured in meters per second squared. So for acceleration, it is rate at which velocity change with time in terms of both speed and direction. Motion graph. The kinematics of a body can be represented graphically. So the most common graph are position time, speed time, velocity time, and acceleration time graph. So this is the example for motion graph that represent for position time, acceleration time, velocity time, and speed time graph. So the position time graph represent that the graph is increment between the position and time, while for the other graph is represent constants, which is graph for velocity time, speed time, and acceleration time.
Now we will move to the next subtopic, which is calculus in kinematics. So what does it actually means? It means that let's given an example that you have a displacement and time graph, but you want to convert it to the velocity and time graph. So you need to use the calculus in kinematic technique, which is to differentiate the displacement and time graph into the velocity and time graph. But let's give an example that you have a acceleration and time graph, but you want to convert it to velocity and time graph. And then you need to integrate the acceleration time graph. So then you will get the velocity and time graph. After hearing the brief explanation about the calculus in kinematics, and now I will explain about how to answer the example questions. So we move to the questions number one, which is a particle P moves in a straight line passing through a point zero. At time ts, the velocity p vm over s is given by v equal to qt plus rt square, where q and r are constants. The particle has velocity 4m over s when t is equal to 1 and t is equal to 2. Okay, so now we will move to the question A, which is show that when t is equal to zero point 0.5, the acceleration of p is 4m over s square. So now we have a t equal to 1 and t equal to 2. So we form an equation and we will get 4 equal to q plus r, equation 1, and 4 equal to 2q plus 4r is equation 2. So we take the equation 1 and we multiply by 2 and we will get 8 is equal to 2q plus 2r. This is our equation 3. And now our equation 2 will be minus by the equation 3 and we will get the answer, which is r is equal to negative 2. So now we have r. So now when we have r is equal to negative 2, we can also calculate the value of q. So we put the r into the equation 1 and we will get q is equal to 6. So now we have r and also we have q. So we put r and q in the equation that they have given in the questions. So we get v is equal to 6t minus 2t square. So a is equal to dv over dt, which is we perform a integration, and then we will get 6 minus 4t. And we solve the equation, we will put the t equal to zero point 0.5 and we will get the answer, which is 4m as negative 2. Okay, now for question B, which is find the values of t when p is at instantaneous rest. So we have an equation that have been given, which is v is equal to qt plus rt square. We take the value of q and r that we have calculated just now in section A, and we put it in a quadratic equation. When the object or particle is at rest, so the velocity will become zero. So we put zero on the v, equal to 6t minus by 2t square. So we solve this quadratic equation and we will get t equal to 0 second and t equal to 3 second. Question C, which is the particle is at 0 when t is equal to 3. Find the distance of P from 0 when t is equal to 0. So, we have an equation of V equal to qt plus rt square. As I mentioned in the calculus of kinematics, when you have a velocity time graph, you have to convert it into the displacement time graph. When you want to convert it into the displacement, then you need to integrate the equation. So we integrate the equation of V, and we will get 3t square minus by 2 over 3t cube plus c. So at t equal to 3, s is equal to 0. We put the equation into the integration, and then we will get 0 is equal to 27 minus by 18 plus c, and we will get the c is equal to negative 9. So all of the information that we have collect, we put it into the equation that we have already integrate at the first step. So now we will get s is equal to 3t square minus by 2 over 3t cube minus by 9. We solve this equation and then we will get t is equal to 0 second when s is 9 meter. Example question 2. A particle moves in a straight line starting from rest from a point 0. The acceleration of the particle at time ts after leaving 0 is a m over s square, where a is equal to 5.4 minus by 1.62t. So now we will answer the question A, which is find the positive value of t at which the velocity of the particle is 0, giving your answer as an exact fraction. So we put an equation which is v is equal to 5.4 minus by 1.62t. So, as I mentioned in the calculus of kinematic, when you have an acceleration and time graph and you want to convert it into velocity, you need to integrate. So, we integrate the equation and we will get 5.4t minus by 0.81t square plus c. So we solve the equation and we put the v is 0, and then we will get t is equal to 20 over 3 second and t is equal to 0 second.
Okay, next I will explain about formula for constant acceleration. Alright, if a particle is moving in a straight line with a constant acceleration, then there are 5 equations of motions that can be used to determine missing quantities, which is the ZIAD formula, where s is displacement, u is initial velocity, v is final velocity, a is accelerations, and t is time taken. Meanwhile, for vertical motions, the acceleration due to gravity is g, which is 9.8 meter per second square. So what are the Suvat formula? There are 5 formula, which is the first one is v equal to u plus at. The second one is s equal to 1 over 2 times u plus v times t. And the third one is s equal to u t plus 1 over 2 at squared. And the fourth one is s equal to vt minus 1 over 2 at squared. And the last one, which is v squared equal to u squared plus 2as. Now let's we look at the example 1. A car traveling at 6 meter per second accelerates at 2 meter per second square. Calculate its speed at 8 seconds later. So given u is 6, a is 2, and the time is 8. Now let's we find the v, which is final velocity. We can use the formula v equal to u plus at, and we substitute the value, which is 6 plus 2 times 8, and we will get the answer for final velocity, which is 22 meter per second. Now we move to the second example, which is a car initially traveling at 8 meter per second and then accelerates at a constant rate of 3 meter per second square until it is traveling at 17 meter per second. And then find A, the distance traveled while accelerating, and B, the time taken to accelerate. Now we can find the information. We will get the u, which is initial velocity, is 8, and final velocity is 17, and the last one is acceleration, which is a equal to 3. And then we can find and answer the first question, which is they want to know the distance traveled. So we can use the last formula, which is v squared equal to u squared plus 2as, and then we substitute the given information into the equation, and which is 17 squared equal to 18 squared plus 2 times 3s, and then we will get the answer for distance, which is s equal to 37.5 meter. And then let me move to the second one, which is they want to know the time taken to accelerate. So from previous question, we find the s, which is distance traveled, and we can use the information in this question because we use formula that contains s, which is s equal to 1 over 2 times u plus v times t. And we substitute the information, which is 37.5 equal to 1 over 2 times 8 plus 17 times t, and we will get the answer for the time taken to accelerate, which is t is 3 seconds. So let's we look at the example 3. This example is a vertical motions, which is object at a free fall accelerated toward the ground at a constant rate. The question is, a ball is thrown vertically downwards from the top of a building at a speed of 2.5 meter per second. If the height of the building is 20 meter, find A, the speed with which the ball hits the ground, and B, the time taken to accelerate. So now let's we look at the first one, which is they want to know the speed with which the ball hits the ground. We can use the formula v squared equal to u squared plus 2as, and we substitute the value into the formula, which is v squared equal to 2.5 square plus 2 times 9.8 times 20. Why we use 9.8? Because this is a vertical motion questions. And then for the accelerations, we substitute with g, which is 9.8. And then we calculate until we get the answer for final velocity, which is 19.96 meter per second. And then let's we look at the B, which is they want to know the time taken to accelerate, which is we use the formula S equal to ut plus 1 over 2 times at, and we substitute the value, which is S equal to 20, u is 2.5 and A. A is G, right? So A is 9.8 times T. So we calculate and we can get the answer for time is T is equal 1.78 second.
So now let's take a look at the past year's questions. We will try to answer few questions regarding the topics that we had been learned before. Past year, which is from January 2024. It have three parts, which is A, B, and C. For the first questions of January 2024, which is 3A, an athlete is running 400 meters. He accelerates uniformly from rest for the first 10 seconds, reaching a speed of 7 meters per second, and maintaining this speed for 30 seconds. After a total time of 50 seconds, he finished the race. Sketch the velocity time graph for the athlete's run. So for the first questions in January 2024, it also asked us to sketch the graph, the velocity time graph. So what we need to have is the velocity and the time taken. So the first velocity is already been given, which is 7 meter per second, and it says that the athletes maintaining the speed for 30 seconds, and then after a total of 50 seconds, he finished the race. So from the graph, we need to plot it from 0 to 7, and then it says that the athlete maintained the velocity, which is it does not accelerate. So the graph will be a straight line only, and then after that he finished the race, meaning the graph will be back to the x-axis. The time taken used is 50 seconds. So the second part of the question, which is B, two particles are traveling along a straight line AB of the length 20 meters. At the same instant, one particle starts from rest at A and travels toward B with a constant acceleration of 2 meters per second, and the other particle starts from rest at B and travels toward A with a constant acceleration of 50 meters per second. Find how far the particles collide. So first, we need to write all of the information we have. For particles that start from A, particle 1, the initial velocity is 0 and the acceleration is 2 meters per second. While the other particles that start from B, the initial velocity is also 0, but the acceleration is 5 meters per second. So next, the first thing you need to do, you need to find the distance, or you need to find the s. We can use the formula ut plus 1 over 2 at squared. So for both particles, we will get for particle 1 t squared. The particle 2 is 20 minus 2.5 t squared. So the second step you can use, you need to find the time collisions. So how to find the time collisions? You just need to equal particle 1 equal to particle 2. Then substitute all the value of s, which is the t squared equal to 20 minus 20.5 t squared. Then you will get the value of t, which is 2.39. And then if we take a look back at the question, it asks to find how far from A the particles collide. So it mentions we need to find the total distance of, it's not the total distance, but the distance travels from particle A, which is we just need to substitute the value of t, which is 2.39, and then square, and we will get the distance, which is 5.71 meter. So now let's take a look at the last parts of the questions, which is part C. A rocket is fired vertically upwards from the ground. After 1 second, it has reached a height of 50 meters. Calculate the initial velocity of the projection. So first, to find the initial velocity, Okay. First of all, you need to write all of the informations you have. For gravity, you have negative 0.98, 9.8, negative 9.8, and the distance, which is 50 meter height, and the time taken is 1 meter, 1 second. So you can use the formula S equal to UT plus 1 over 2 AT squared if you take a look all of the information you have. So then you will get the initial velocity 90, 19.9 meter per second. So the second question, it asks to calculate the length of time during which rocket is higher than 50 meter. So first, the same step, write all of the information you have. So now we have the S, which is 50, initial velocity 19.9, the gravity A negative 9.8, and time taken we don't have because we need to find it. Also the same, you can use the formula S equal to UT plus 1 over 2 AT squared. So for the value, so we need to find the value of T, right? After you substitute it, you will get two value of T, which is 3.06 and T equal to 1. But if T equal to 1, it is exactly 50 meters. So we'll ignore the value of that value. So the answer is T equal to 3.06. The And the next question, which is part C, a ball A falls vertically from rest top of a tower 85-meter high. At the same time as A begins to fall, another ball is projected vertically upwards from the bottom of the tower with speed 21 meters per second. The two balls then collide. Find the height of the point where the balls collide from bottom of the tower. Okay, so I will write all of the information I have first for balls A and for balls B. For the initial velocity of balls A is 0, while the initial velocity for balls B is 21. For acceleration, balls A 9.8, while balls B negative 9.8. And for the distance, for balls A is 85, for the balls B is 0. So first we need to find the distance for both balls A and balls B. And then we will get the equations 85 minus 4.9t for balls A, and for balls B 21t minus 4.9t squared. So to find the value of t, I will put it in the equation, which is as A equal to as B, which means the distance A and distance B is equal to each other. And then after that, you just need to substitute the equations and you will get the value of T, which is 4.05. And then it mentions we need to find the height of the point where the balls collide from the bottom of the tower. So you just need to substitute by using the formula of distance balls B because it's from the bottom of the tower. So we will get the distance is 4.68 meters. Okay, we already done all of the past questions. I hope you will understand all of the past questions we discussed in together. So for the conclusion, I would like to highlight the key points you as the students need to remember. The first one, which is the equations of motion. This SYAHIDA equation is very important for you to solve all the equations in your examinations. And also this is a few tips I provide for you to answer all of the questions, which is first, I hope you can identify the given value, which is you need to identify the initial velocity, the final velocity, the acceleration, time taken, and also the speed and displacement distance. And also you can decide whether to use the equations or the graph. And also I hope you can consider the directions of motion, whether it's the positive or the negative one. It's also the same with the gravity value, which is we have the negative value and also the positive value. I hope you will remember all of the things that had you learned from the first until the last one of this lesson. Last but not least, I would like to say thank you for all of you for lending your ears hear to hear our lessons, and I hope you can remember all of the lessons we're giving together. Thank you everyone.